What if I told you scientists had discovered a new state of matter that seems to ignore one of the most basic laws of physics, something that ticks on its own, forever, without needing any energy, like a clock that never, ever needs to be wound? They're called time crystals, and for the longest time, physicists were convinced they were impossible. But this isn't science fiction. It's a real discovery that's forcing us to question our understanding of reality itself. We're talking about a completely new phase of matter, one that seems to run on its own internal clock, endlessly. The question is no longer if they exist, but what we can do with them. This discovery could unlock technologies we've only dreamed of, from nearly perfect quantum computers to sensors that can detect the undetectable. We are stepping into a whole new era of physics. The old world. How reality is supposed to work asterisk, to get why this is so revolutionary. Let's first talk about something you see every day. A crystal. Think of a diamond or even a tiny grain of salt. What makes it a crystal? It all comes down to order. Its atoms aren't just a jumbled mess. They're arranged in a perfectly repeating pattern in space. Imagine a huge 3D grid, with an atom at every single intersection. This rigid structure is what gives crystals their unique properties. This repetition in space is a kind of broken symmetry. While the laws of physics are the same everywhere you go, the crystal itself isn't. It has specific spots where atoms are, and empty spaces where they aren't. This idea of spontaneous symmetry breaking is a cornerstone of physics, explaining everything from how water freezes into ice to how magnets work. For more than a century, that was the deal. Matter could have order in space. But time was different. The laws of physics are supposed to be consistent through time. What works today should have worked yesterday, and should still work tomorrow. This is called time translation symmetry, and it is directly tied to one of the most sacred rules in all of science, the conservation of energy. The idea that something could just break this symmetry on its own, that it could have a repeating pattern in time without any outside push seemed impossible. It sounded a lot like a perpetual motion machine, something science had thrown in the fantasy bin a long time ago. The universe, according to the second law of thermodynamics, is always supposed to move toward more disorder, more randomness. That's a concept called entropy. Any system should eventually run out of steam and settle down, not dance to its own beat forever. So, for a long while, a crystal that repeated its structure in time was just a cool, but impossible, thought experiment. The impossible problem, a clock that shouldn't tick asterisk, the story of the time crystal started with a what if. In 2012, Nobel Prize-winning physicist Frank Wilczek was teaching a class on regular crystals and their repeating patterns in space. He threw out a wild question. If crystals break symmetry in space, could a physical system spontaneously break symmetry in time? Could you have a material that, in its lowest energy state, its most natural, settled state, would just tick? Not like the clock on your wall that needs a battery, but something that moves in a repeating cycle all by itself, forever, without using up any energy. The scientific community was instantly fascinated and deeply skeptical. The idea sounded suspiciously like a perpetual motion machine, which would violate the universe's ultimate rule, the second law of thermodynamics. This law says that things fall apart, they lose energy, and they settle into a state of disorder, or what's known as thermal equilibrium. Think of a hot cup of coffee. It doesn't stay hot. It cools down until it's the same temperature as the room. That's equilibrium. Wilczek's original idea for a time crystal, in its most basic ground state, was proven to be impossible for exactly this reason. Any system should eventually settle down and stop moving. An object that oscillates forever would be creating order out of thin air, defying the universe's relentless march toward chaos. It was a beautiful idea, but it seemed dead on arrival. The breakthrough, the aha moment but physicists are a stubborn bunch. If an idea is beautiful enough, they'll look for a loophole. And in the bizarre world of quantum mechanics, there are always loopholes. The key was to change the question. What if the time crystal wasn't in a state of perfect, boring equilibrium? What if it could exist in a special, stable state that was constantly being poked, but in a way that it didn't heat up and fall apart? This led to the idea of a discrete time crystal. The trick wasn't to expect it to move on its own, but to drive it with a repeating pulse of energy, like a laser blinking on and off. Now, normally, if you keep kicking a system, it's going to absorb that energy, heat up, and its particles will start flying around randomly. That's what thermodynamics says should happen. But scientists figured out that, in certain quantum systems with some built-in disorder, a weird phenomenon called many-body localization could stop this. The particles essentially get stuck, unable to absorb energy from the laser pulses. Instead of heating up, the system does something incredible. It falls into a synchronized rhythm, but at a different frequency than the push it's getting. Imagine you're pushing a kid on a swing every 2 seconds. In a time crystal, it's like you push every 2 seconds, but the swing only completes a full cycle every 4 seconds, or 6, or 8. The system picks its own better multiple of the push and locks into it. This is the broken time symmetry Wilczek imagined, but brought to life in a clever, roundabout way. The first real proof came in 2016, when researchers at the University of Maryland and Harvard finally created these strange new phases of matter. Since then, the field has exploded. Scientists at Google used their Sycamore quantum processor to build a time crystal out of 20 quantum bits, or qubits, proving how stable it could be. Researchers at QTech in the Netherlands made one inside a diamond that was even more stable. More recently, teams have created time crystals with gigantic Rydberg atoms, and even a time quasicrystal, which ticks in an ordered but non-repeating pattern, adding another layer of weirdness. The implications: a new world of technology, asterisk. Okay? So we've made a new phase of matter that ticks forever. What can we actually do with it? This is where things go from a cool science experiment to a potential technological revolution. The possibilities are mind-boggling, especially for the future of computing. The biggest promise is in quantum computing. Quantum computers get their incredible power from qubits, which are notoriously fragile. The tiniest vibration or change in temperature can wipe out the delicate quantum information they store. But time crystals are naturally tough. Their periodic motion stays locked in, even when the laser pulses driving them aren't perfect. This built-in stability could be used to create incredibly robust qubits, a kind of quantum memory that could store information for much longer. Quantum version of a computer SRAM. It might just be the key to building a truly fault-tolerant quantum computer. Beyond computing, the perfect, predictable rhythm of time crystals makes them ideal for ultra-precise clocks. Our entire modern world, from GPS to the stock market, runs on precise timekeeping. Time crystals offer a new way to create a stable frequency that could lead to clocks that are orders of magnitude more accurate, and their extreme sensitivity could be used for advanced sensors. Because a time crystal's rhythm is so stable, any tiny nudge from an external magnetic field, for instance, would be easy to detect. This could lead to hypersensitive sensors with unbelievable accuracy. Researchers are also looking into photonic time crystals that could amplify light in new ways, potentially transforming everything from telecommunications to medical imaging. We're just starting to figure out what's possible. We've found a new corner of the universe to explore, and with it a new set of tools to build the future. The discovery of time crystals has totally expanded our definition of what matter can even be. We're watching a new field of physics be born right before our eyes, and the breakthroughs are happening faster than ever. If you want to stay on top of how these incredible discoveries are changing our world, make sure you subscribe and ring that bell. And let me know in the comments, what is the most exciting application of time crystals for you? From an idea that seemed to break the rules of physics to a real thing built inside diamonds and quantum computers, the journey of the time crystal has been nothing short of amazing. They aren't perpetual motion machines in the classic sense, but they might be just as profound. They're the first example of a phase of matter that is perpetually in motion but totally stable, existing in a state that was once thought to be forbidden. This discovery is so much more than just a new material. It forces us to rethink our most basic ideas about time, order, and what it means for something to be at rest. It shows us that even the most established rules of the universe have some pretty wild exceptions. When you dive into the quantum world, we've literally created a crystal that repeats in a fourth dimension, a clock that ticks to its own quantum beat. The discovery of time crystals has opened a door to a new where the building blocks of the universe can dance forever.